Hey, Jocelyn, you're here.
Yeah, so you want to play basketball with me, huh?
Yep, you told me that you're good at this game, right? So let's play it and see which of us score more points in 1 minute.
Sure.
So, Jocelyn, I scored 44 points in 1 minute. What about you?
I scored 33 points in 1 minute.
Hey, I thought that you said you're good at points, but now you've lost to me.
Well, don't judge so soon. Let's shoot another 9 rounds against a total of 10, and we'll see which one of us will score more points in 1 minute.
Sure, let's do that. And you're set to lose flat out. Now, this is the outcome of my 10 rounds. I scored a total of 320 points.
This is a total of my 10 rounds. I also scored 320 points. In 10 minutes, we both scored 320 points. So, who did better?
Now, since we already have the results of 10 rounds, so why don't we compare results?
How do we do it?
Now, that's easy. First of all, let us arrange the raw data from the lowest scores to the highest scores, and then we will measure the central tendency. In 1 minute, my average score is 32. The median score is 32, while the mode score is 32.
In 1 minute, my average score is 32. The median score is 32, while the mode score is also 32.
The mean, the median, and the mode of our scores are both 32. It is a tie, so both of us are winners.
If we compare the central tendency, our performance are the same. However, my performance was relatively more steady, but yours was,
What evidence have you to say that your performance was more steady?
Well, you don't have to argue. Our respective performances will be clearly shown if we plot our scores of these 10 rounds on a number line. According to the number line, it is shown that your scores are scattered, while relatively my scores are clustered at the mean score. So my performance was more steady.
We cannot determine the distribution of data merely by its central tendency. We also have to consider the degree of distribution of data.
That's right. In statistics, the degree of distribution of a set of data is called dispersion. Also, the central tendency is to reflect the location of a concentration of various data in a set of data.
In the following, we will discuss some methods to measure dispersion.
The ways to measure dispersion include range, interquartile range, box and whisker diagram, and standard deviation.
Okay, so first of all, let us talk about range. Range is the difference between the largest datum and the smallest datum in an ungrouped set of data. In a set of grouped data, range is the difference between the upper class boundary of the last class interval and the lower class boundary of the first class interval. So, the larger the range of this data set, the wider the spread of the data.
The range is the simplest and easiest way to measure dispersion.
Based on our scores in the 10 rounds, the range of my scores is 32.
And the range of my scores is 5. The range of my scores is smaller than yours. That is to say, my scores are more concentrated, while yours are more dispersed. Just now you're discussing the calculation of range in a set of ungrouped data. So what about the calculation of range in a set of grouped data?
In a set of grouped data, the calculation of range is like this. In this example, the highest in the class boundary of body weight is 69.5 kg, while the lowest is 44.5 kg. The range of body weight is 25 kg.
Have you noticed that in calculating the range, only the largest data and the smallest data are used? The value of the range is only affected by these two data. If there exists extremely large or small value, then the range is not an appropriate indicator of dispersion. The second method to measure dispersion is called interquartile range. Let's consider a set of data arranged in ascending order. There are 3 values dividing the set of data into 4 equal parts. These values are called quartiles. Q1 the first quartile, Q2 the second quartile or the median, Q3 the third quartile.
The interquartile range is defined as the difference between the third quartile and the first quartile, that is Q3 minus Q1.
Let me use the interquartile range to illustrate my scores. In my scores for the 10 rounds, the first quartile is 22, the third quartile is 44, so the interquartile range is 22 points.
For my scores, the first quartile is 31, while the third quartile is 33. The interquartile range is 2 points. The larger the interquartile range, the wider the spread of data.
Since the calculation of interquartile range will not be affected by the extreme values of the set of data, so interquartile range is a more reliable measure of dispersion. In a set of group data, the way we calculate interquartile range is like this.
Firstly, we construct a cumulative frequency table. We make use of the cumulative frequency graph or other calculation method to find out the third quartile and the first quartile. The first quartile, Q1, is 54. The third quartile, Q3, is 62.75. The interquartile range of body weight is 8.75 kg.
If we compare the dispersion of two sets of data by using range or interquartile range, the quantities of these two sets of data must be more or less the same.
The third method to measure dispersion is to use a box and whisker diagram. The box and whisker diagram is also called box plot. It is constructed above a number line with a rectangular box and a pair of whiskers at two ends. It can simultaneously show the largest datum, the smallest datum, the median, the first quartile, and the third quartile of a set of data. In the box and whisker diagrams, the values of the whiskers at the two ends of the box shows the range, and the length of the rectangle box is the interquartile range.
Also, box and whisker diagram comprises 4 portions, and that is the two whiskers, the two parts that separates by the median in a rectangular box. Each portions contain 25% of the data.
Let's refer again to my scores in the 10 rounds of the basketball game and draw a box and whisker diagram. The largest datum is 50. The smallest datum is 18. The median is 32. The third quartile is 44. The first quartile is 22. In the box and whisker diagram of my scores, you can see the 5 significant statistical values of my scores.
In my set of data, the largest datum is 35. The smallest datum is 30. The median is 32. The third quartile is 33. The first quartile is 31. In the box and whisker diagram of my scores, the 5 significant statistical values are shown as such.
The box and whisker diagram can also be placed vertically. Using my scores, the box and whisker diagram shown vertically is like this.
If the box and whisker diagram is already known, we can read from it the 5 statistical value, and that is the largest datum, the smallest datum, the median, the first quartile, and the third quartile. With these values, we can find the range and the interquartile range.
So Jocelyn, in order to use the box and whisker diagram to compare the dispersion of the two sets of data, all we need to do is to draw 2 box and whisker diagrams on the same number line.
Using the scores of our basketball games as an example, we can use the box and whisker diagrams to compare the dispersion of the two. From the 2 box and whisker diagrams on the same number line, it is clear that both the range and interquartile range of men's score are larger than the women's score. Therefore, the men's score is more dispersed.
1 point to supplement, on the same number line we can draw 2 or more than 2 box and whisker diagrams to compare the distribution and to measure the dispersion of the different sets of data. Previously, we've discussed about the range, the interquartile range, the box and whisker diagram. They involve only some but not all of the data, and therefore they cannot precisely or accurately tell the spread of the whole set of data. Here's an example for you. Let's take a look at the body weight of these 2 groups of people.
For these 2 sets of data, the largest datum the smallest datum, the median, the third quartile, and the first quartile are all the same. Therefore, the range and the interquartile range are also the same. However, the level of dispersion of these two sets of data are not the same. We plot the data on the number line. They are presented like this. We can clearly see that the data of Group B is more dispersed than Group A.
After listening to your description and reading the statistical diagrams, we in fact need a measure of dispersion that takes every datum into account, instead of considering the largest datum, the smallest datum, the median, the third quartile, and the first quartile.
So, in the following, we will discuss a measure of dispersion which can show the level of dispersion between the data and the mean, and it is called standard deviation.
The difference between the data and the mean is called deviation. For each data, after deducting the mean, square the results. Work out the average of the deviation square. The result is called variance.
Even though variance is a measure of dispersion, but the unit of variance is different from that of the raw data.
That's because it's the square of the result.
In order to be more effective in comparing and analysis, we take the positive square root of the variance as the measure of the dispersion. It is standard deviation. And the formula will be applied to the set of ungrouped data. And for the set of grouped data, the formula looks like this.
x1, x2, x3, etc. are class marks of intervals, and f1, f2, and f3, etc. are corresponding frequencies. When we look at the previous two sets of data on body weight, we calculate the standard deviation of these two sets of data, and then compare which set of data is more dispersed. After calculation, the standard deviation of Group A is 14.2, while the standard deviation of Group B is 17.4. As 17.4 is larger than 14.2, that is to say, the data of Group B is more dispersed than Group A. This result agrees with the conclusions drawn by plotting the data on the number line.
We can also use the statistical functions of the calculator to find out standard deviation. Let me use the calculator to find out the standard deviation of our scores of the basketball game. If we look again at our scores in the 10 rounds of the basketball game, your standard deviation is 10.8, and the standard deviation of my score is 1.55. That is to say, your scores are more dispersed, and my results are more close to the mean, and my performance is more stable than yours.
With the help of a calculator, there's more time for comparisons and analysis.
Okay, please calculate the standard deviation of a set of grouped data.
Alright, so let me use the 30 people's body weight again as an example. In order to calculate the standard deviation, I divided them into 5 groups.
The mean of the grouped data here is 58.17. The standard deviation is 5.87.
If we compare the data of two sets or above, the larger the standard deviation of the group, the wider the spread of the data of this group.
In the previous discussion, it was mentioned that there is no negative value for the standard deviation. The larger the value of the standard deviation, the more dispersed the data is.
What if the standard deviation is 0?
That means all data are the same.
To measure dispersion, we've discussed how to use range, interquartile range, box and whisker diagrams, and standard deviation. So, will you please conclude which method under what circumstances is a suitable measure of dispersion?
Okay, let's look at the table. It will help choose the suitable measure of dispersion. When we become familiar with different kinds of measure of dispersion,
We can choose a suitable measure of dispersion for data analysis under different conditions.